Okay, hi there, this is Mr. Ndelovet, your physics teacher. So today we'll be looking at vectors and scalars, and it's the second topic on mechanics. So it's very important. The previous topic on video, we were looking at physical quantities, and we said physical quantities are the building blocks of physics, and they are divided into base physical quantities and derived physical quantities. That's what we said. And these two, they form the physical quantities. And we said physical quantities, and we give a lot of examples. We have pressure, force, mass, time, current. So these quantities are further divided into two. And further divided into two, as we will see, is we have vectors and we have scalars. Now, the next thing, what are vectors? We know that base quantities are quantities that cannot be expressed in other physical quantities, and derived ones are the ones that are obtained by either multiplication or division of base physical quantities. Now, what are vectors and what are scalars? So we have vectors quantities. So vectors scalars now. Vectors are the quantity that has magnitude and direction. But now, scalars are quantities that have only magnitude and no direction. So scalars are quantities that has both magnitude, has only magnitude and no direction, while vectors are quantities that have magnitude and direction. Now, what are examples of vectors and scalars? What are the examples of vectors and scalars? Vectors, now, examples of vectors that we know are forces, we have acceleration, we have weights, we have the momentum, we have velocity, and so on. And then we have example of scalars. We have mass, we have time, we have current. No, we have not current. We have mass, time, distance or length. We have speed. We have speed, and there are lots more. So it's very important for you to also make a table in your book or in your book somewhere and try to differentiate all these physical quantities into vectors and scalars. Now, vectors has a way of representation. How do you represent vectors? You always read them. You always write a symbol and with an arrow. This arrow, this is a head and this is a tail. This arrow represents the direction, tells you the direction of the vector, and the length of this arrow tells you the magnitude. Tells you the magnitude. Now, if the length is bigger, for example, if I have three things like this, three vectors like this, and I have C like this. All of them are moving the same direction, but their magnitude is different because this distance are different. So you see that C is greater than B, and B is greater than what? Than E in magnitude. So A, because they have different length of their of the length of their arrows. So we say the arrowhead tells you the direction, and the length of the arrow tells you the magnitude. So now, all vectors must be presented like this, and scalars are just like this. So if I see any letter symbol with an arrow on it, I know that it's a vector. And if I see a letter like this, I know this is scalar and this is a vector. A magnitude of a vector is going to give me A. It's going to give me a scalar per se. Now, how do we add vectors? Now, vectors, addition of vectors are very important for us as physics students. So how do we add them? So we add vectors by combining the head to the tail and the head. So how do we do that? For example, I have a vector like this, and I have another one like this, that is straight. So you have, this is a head, this is a tail, and this is a head, this is a tail, and this is a head. So we have F1 and this is F2. For me to add these two vectors, I have to draw first. I have to draw the vector. The first one, let me say this is mine, is F2, quite why it's horizontal. The next one will start by from the head of the first one, so I'll draw this. And so you have to maintain, what you have to do, you have to maintain the direction and the size of the vector. Now, the resultant of the vector, the sum of these two vectors will be the one that joins the tail of the first to the head of the second. So let me use another light to make it so you see it clearly. So B, the one that joins, so this now will be the arrow, which is the sum, the resultant. So resultant is the sum of F1, F2, and F1. So the sum of the vector is the line joining the head, the tail of the first to the head of the second. So that's the resultant. So in adding vectors, there are two ways in which we're going to look at your level. We are going to look at the additional, the parallel vectors and non-parallel vectors. So parallel vectors, let's look at parallel vectors first. Parallel vectors. Now, in looking at parallel vector, means you are saying vectors are moving side by side each other like this. So the first thing in doing adding vectors, you have to check which direction are they moving. Are they moving the same direction or they are moving in opposite direction? So when you first, let's change the color. So when you're looking at opposite direction, for example, the same direction, let's say we have this and this. This is 2 newtons and this is 2 newtons, for example. The first you check, choose the sign of that direction. Let this direction have positive sign. Means that my resultant vector, which is the sum of the vectors, will be 2 newtons plus 2 newtons, which give me what? 4 newtons. Now, if they are moving in opposite directions, like this one is moving and this one is moving like this, this is 2 newtons and this is 2 newtons. So what do you need to do? You have to choose a sign. Let's say this one is positive and this one is negative. It depends on you. You can choose the first one to be negative and the second be positive. So my resultant vector now will give. So this one is positive, you have 2 newtons. The next one is what? Negative. So you put minus what? 2 newtons. So you see your answer gives you what? 0 newtons. And any vector that has the sum of them is giving 0. It tells you one thing, that the forces acting on the body, their sum is 0. And because their sum is 0, it means the body is at rest. Take note, it means that the body does not move, or it is moving with constant velocity. It means it's moving with constant what? Velocity. So it means that the body is at rest or is moving with constant velocity. So you need to take note. So any body that has the sum is 0, it means they are moving with constant velocity, or they are at rest, right? So now how do we add vectors that are, so I'm saying adding vectors that are parallel vectors, you have to first choose a sign. If they are moving in the same direction, okay, you say, okay, which sign should I give? I can give positive. Then you add. But if they're moving in opposite direction, you say one side should be positive and the other should be negative, and then you add them. But now, if the vectors are not parallel and they are perpendicular to each other, for example, I have this. For example, I have something like this. Okay, these two vectors. This F1 and this F2. Now, they are perpendicular because this is 90 degrees. How do we add them? I said in adding vectors, we make the head to the tail because here is tail, right? It's tail. So instead, you can redraw it like this. This is my tail, this is my head, this is my head, and this is my tail. So I'll join like this. Now they are moving in the same direction, so this line is the same as this one, and this one is the same as this one. So I said the resultant vector will be the vector from the tail of the first to the head of the second. So I'll draw like this. So this is my resultant vector. So, and this is my 90 degrees. So you see that this triangle up here has, and this one have formed now a triangle. So this line is same as a line here. This arrow is same as this. So this same as arrow. This arrow is same as this one, and this one is same. So you have seen it has formed now a triangle. So in this triangle now is the right angle triangle. We are going to apply the Pythagoras theorem. This F1, this F2. Okay, no, this F2 and this F1. So we are going to apply the Pythagoras theorem in order to look for what? Arrow, right? And I said to look for arrow, which is the hypotenuse. So hypotenuse by Pythagoras theorem is equal to the square root of adjacent squared plus opposite squared. So at times they're always asking you to, we can give an angle theta. Is the angle between the forces F2 and F1. So we see that in applying this, using this Pythagoras theorem in this case, we are going to have it represents arrow represents hypotenuse. So we have arrow is equal to. Now, if we are using this angle, the opposite of this angle is F1. So we have plus F1. So this one will be equal to this all squared. And this man will be equal to this. So we have F2 all squared. So this is how we can look for it. For example, if you have two vectors like this, minus 2 newtons, and this minus 2 newtons. How do we look for r, which is the vector? The resultant. The resultant of the r will be equal to the square root of 2 all squared plus 2 all squared. So it gives you the square root of 4 plus 4, which gives you the square root of what? Of 8 newton. So this will give you the resultant of the vector. But now, in the case that you are not given now these two, you're not given this side and you're not given this side, what were you going to do? Now in this side now, so what means that they'll give you the vector like this, and they'll say the resultant vector here is 5 newtons. Find the x and you find the y component. It means that you find f1 and you find what? F2 vector. How do you do this now? Now we can do this by following the same Pythagoras theorem. How does that work? You see, when we're doing trigonometry, we said this vector here is the same as this vector. Pair this diagram, right? So this one like this, like this. So this angle here is theta. We said if the angle is theta, we say sine theta is always what? Opposite over hypotenuse. And cos theta is equal to adjacent over hypotenuse. So in this case, if you are looking at that, you'll see that sine theta here, what will be the angle? What is the opposite side? The opposite side is F2, which is this. It will be F2 over hypotenuse, which is R. This 5 stands for R, right? It will be equal to R. Now, for me to look for this F2 now, by change of formula, since this man is below the line, I take this arrow this way. So my F2 will be equal to r times sine theta. That's what I'm going to have. Now, if I want to look for the other case, that we have, so we have cos theta. Cos theta will be equal to which adjacent hypotenuse. So my adjacent now will be this one, which is f1. So it will be f1 over hypotenuse, which is r, which arrow is this one. So you take this one now, since you're looking for f1, so you take this arrow to this side above the line, because this one is like this. So you have now f1 will be equal to arrow cos what? Theta. So this is how you look for the two sides. So this side is the y component, and this one is the x component. So now, if we look at it very well, we can look for example. For example, if I have this one now, okay, if I have this is my x and this is my y, for example, and this one is 5 newtons, and this angle here is 30, for example. So what is x? So your x now will be equal to, x value now will be equal to, you have the arrow cos theta, which will be same as the arrow here is 5, cos, the theta is 30, so it will be cos 30 degrees. So you see that will be 5 times root 3 on 2. So your answer will give you 5 root 3 on 2. You can allow like this, or you try to simplify it, no problem. Then your y component will be equal to arrow sine theta, which will be equal to, arrow gives you 5, sine theta is what? 30. So you have 5 times half, which gives you 5 on 2. So this will give you your xy component. So in physics, when we divide, when we are able to split a vector, this one, when we're able to split a vector, this, into two components, this and this, the component you have x and you have what? Y, is what we call resolution of what? Vectors. We call it resolution of vectors. So resolution of vector means resolution of vector. It is splitting of a vector into two components. You have the x component, I have the y component. So the x component is always given as arrow cos theta, and the y component is given by arrow sine theta, where arrow is a resultant, and theta is the angle. So now we can look for more examples. For example, if we have this one, like say this one, we have, this is 20 newtons, and this man is, the angle here is 60. Then we have the axis to look for x and look for y. So your x will be equal to arrow cos 60, which will give you 20 newtons cos 60 newtons. 60 degrees, sorry, will give you 20 newton times half, which your answer will give you what? 10 newtons. And the y component will give you arrow sine 10 theta, which will give you 20 newtons sine 60 degrees, which will give you 20 newtons times root 3 on 2, which is same as 10 root 3 newtons. This one is 1 and this one will give you 10. And that's how you solve it. Now, in another case that they give you something which is parallel, right? Which is something that is parallel. Mm, yes, they give something that's parallel. So we have two forces moving in this direction. This is 4 newtons. I have another force moving in this direction, that is 7 newtons. So you choose the direction positive. So my direction here will give me R will be equal to 4 newtons plus 7 newtons, which will give you what, 11 newtons. I say if they are moving in opposite directions, like this man is moving and this man is moving, we have 2 newtons, I have 5 newtons. So our rule now will be equal to, this one is positive and this one will be negative. So I have minus 5 newtons plus 2 newtons. And I'll have my answer to be minus 3 newtons. So now, if you have your direction to be minus, it means that the resultant vector here will move by in this direction because it will follow the direction of the negative sign. In this case, the resultant vector will move forward in this direction because it is positive. So if the direction of the resultant vector is negative, it means that the resultant vector will be moving in the direction of the vector that was negative. If the resultant vector was positive, then the resultant vector is moving in the direction of the vector which was positive. So that's how it works. And here also, some you think that there's no positive and negative. There is, because when you have this man is positive, if my direction is positive, if I also put like this, it means that this man is also what, positive. So you see my resultant vector will be from this tail to the head here, and it's moving up also. It means that it will also be what, positive. There's a cases that this man can also be moving what, downwards, and he's moving downward negative. Your answer might also change with time. It's okay depending on the direction on which you're choosing. So you always make sure that you have direction chosen. Thank you for watching, and thank you. If you want more questions or videos, or subscribe to the channel, and also if you want for me to help you more, click on my WhatsApp group, WhatsApp link on the description below, so that we can give you more questions and also confirm whether the exercises you've done are, are okay, are correct, or to clear any doubts that you have. Thank you once again.